All right, hey, welcome back, boys and girls. Today we have this K-tuned billet K-series gear shifter. Only this isn't actually a K-tuned. This is some Chinesium copy made by some manufacturer in China land. But it is pretty decent machining, and it is a pretty faithful copy of the K-tuned shifter, but as with a lot of these different copies out of China, they're able to copy a lot of the design, but they can't copy some of the precision and just sort of quality of the part. The upside is they are a lot cheaper. This was, I think I paid $109, something like that, off of eBay, and the K-tuned part, I'm gonna guess it's in the, well, I'll put a screenshot of it here, but whatever, like $400 or $500, maybe even more than that. As far as just hogging stuff out of aluminum, like these bigger parts, I mean, that's not that special. That's not that complicated. That's why those manufacturers are able to do it for so cheap. But one thing that they do struggle with is like the nice fit and finish of some of these parts. So what we're going to do is we're going to see if we can't improve some of the fit and finish on this part and make it nearly as good as that $500 K-tune part for a fraction of the price. So if you look a little bit closer here to this, I'm going to call it the shift lever. You can see there's quite a lot of play and quite a lot of wiggle in this part, and it's just not fitting very tightly to the shaft or between sandwiched between these two pieces. And what that results in is, if we zoom out for a second, right, that translates into quite a bit of movement. I mean, this isn't even actuating much of the shift mechanism. This is just wiggle. So that translates into a lot of movement. So we're going to try and eliminate that if we can. And then also this guy, if I can, this guy, even if I hold this steady, this guy's got quite a bit of wiggle as well. So we're going to try and use some machinist tricks, not really tricks, but we're going to try and modify this so that this junk doesn't move around as much. Because overall, right, everything else is actually pretty nicely machined, and I think it'll work fine. We just need to tighten this up. So what I'm planning to do here is, if we take this apart, start to take this apart. This is just held on by a fastener. And so you can kind of see, I'll give you the best view. You can kind of see that wiggle. So I think what I'm going to try and do here is we'll bore this out, this linkage part here. We'll take this off. I think I'll bore it out and press in a bronze sleeve. So I have some bronze stock here. Focus, you fuck. We'll try and make some bushings out of this. And so we'll bore a hole out, push in a sleeve, and allow for a lot less clearance around this shaft to help tighten that up. And we'll basically do the same thing for this shift arm as well. So we'll see. What I'm aiming for is probably around about 1/1000th diametral clearance, and I feel like that'll help tighten this up, as well as we might want to use a small shim or sort of washer, if you will, to try and reduce the amount of play in that. So first we're going to take it apart, see what we got. Then I'll come up with some rudimentary plans as to what dimensions I want for these bushings. For these two parts, this part here and this part, excuse me, you can't see that, this part here and this part there, we'll bore them out and push bushings in there, and we'll see if we can't tighten this thing up. Okay, so we're going to start by taking this guy apart. One thing that's important to note with these is they generally they're not put together they're not put together very well. So a lot of times you'll find that like a lot of these fasteners are pretty loose. So regardless whether or not you're going to try and modify one of these cheap Chinese pieces of shit, you're going to want to go through and make sure all those fasteners are nice and tight. This guy is this doesn't come assembled, so that's my fault. But all the rest, like this fucking bullshit, that comes ready-made just like that from the factory. So you'll want to make sure that all these fasteners are nice and tight. Alright, I'm going to try to just wiggle this off. You gotta sort of wiggle this off and then be mindful of that spring that wants to go spring a spring. It'd be nice if this was a tighter fit, but now I'm not really sure what to do with this because I can't do anything with these bearings. I could probably make another shaft like this, just make a new one that's tighter. And that's kind of the only thing I got going to make this a tighter fit. Alright, figured out what we're going to do. We're going to make a new one of these, a bigger one, so that it fits more tightly. As you can see, there's a little bit of wiggle right there, and that's what's causing some of our sloppiness. The problem is the holes in this carrier. Well, actually, that one's smaller than this one, but the holes in this carrier are fucking smaller than the bore, than the ID of that inner race. So if I'm gonna make a new shaft, maybe I can call it a pin. Yeah, I'll have to bore this out. I have this gauge pin that is a 393. We're just making challenges for this camera today. Anyway, take my word for it. It's a .393, and that fits in that bearing real nice, like. But it does not fit in this fucking. Wait, fuck, it does. What am I talking about? Oh, so I don't have to bore that out. You know what? Never mind. Forget what the fuck I said. I think I just tried to put it in here because I wonder if they staked, whether intentionally or not. They either staked this ridge of this hole, or they just didn't bore it all the way, because it hits a pretty hard stop. I'm sure you can hear that. We'll have to look closely as to what the fuck is going on there. But anyway, so looks like we don't have to actually mess with that. We just have to make one of these that's slightly bigger, i.e. the same diameter as this gauge pin, and then that'll fit nice and snug. That is nice. Probably could do for a 1/10 over that, but yeah, that's a tall order. We're gonna do the best we can, and we'll take you along for the ride. .3899. So almost right. So we need to make a shaft that's round about 3 thou bigger in diameter, maybe a touch bigger than that, because I wouldn't mind if this was a bit of a tight fit in that bearing, and then that'll just all but eliminate that slop. Let's get to it. So I did get this steel bar stock. I'm not sure exactly what it is. This pin is some kind of stainless. I'm guessing this is magnetic. So this guy is not magnetic. This guy is. I hit that with a file. It's pretty soft. I don't know what kind of stainless this is, probably 304. And I've told myself that that's going to be okay. so it's going to be fine. It'll be fine. All right, so I got this bar chucked up in the lathe. It's been a minute or two since I've run this machine, so I'm going to take it easy. But basically, we're gonna take an initial pass. We're starting out at, this bar is 1/2 inch, so we got roughly 1/10 of an inch to take off of this thing. So we'll just work your way through it. And if you're a machinist, then don't make too much fun of me. Well, you can make fun. Yeah, whatever. It doesn't matter. Okay, that was pretty ugly. There was a lot of rubbing and a lot of smoke. So I'm not sure that I want to use that cutting tool. I did say I wasn't an expert. Let me try a nice sharp piece of carbide on that instead. Yeah, I don't know how I feel about it. I'm going to use the critical end where those, I'm going to orient it like this so that the part that matters is closer to this end, and there will be ideally less deflection. Yeah, that didn't go super well. That thing is nuclear hot, and I feel like it probably shouldn't be that hot. But again, I'm not an expert. And we'll have to do something about that finish. I'm just going to play with different tools until I find one that works. I don't have that much material to mess around with until I'm down there, but we'll get there one way or another. Okay, so that was a bit of an ordeal, but we got it. So here's the, hopefully this will focus, you fuck. Here's the original part. Here's the one that I made. Yeah, it's not perfect, but it's got it where it counts. 393.5. So yeah, the result is the original one. Trying to hold that steady so you can see the original one's like that. And when we put this guy in, it sort of barely fits, but there's the only wiggle that there is due to the clearance in the bearing. So that is super tight. That's going to be good, I think. And then move on to this, if you remember this part. So I just have this is just a piece of scrap, but it's something that we can use to hold on to it. So I have a fastener coming into these threads, and then I'm just bolting it down to this piece of scrap so we can get a bore head and bore this out and push in a bushing. Let's keep going. Okay, so we got our linkage piece chucked up in the vise. We have the cheap ass boring head. So what we're going to try to do, what I'm shooting for is 0.550 thousandths, and then I have I turned down that bushing to 0.551 or thereabouts. So we're going to try and basically bore this out so that it's undersized to the bushing, push the bushing in there, and then take the ID of the bushing to final dimension. So if I can remember how to fucking use this thing. Just a tip for anybody using these Chinese boring heads that come with a brazed carbide cutter. You really need to grind these. You need to grind them down so that, if you can see that, so that the cutting edge is as close to the axis of rotation as possible. The way that they come from the manufacturer. It looks kind of like this. So you can see that this cutting edge is not along the center line, right? Is not along the center of the cutting tool. If I position it like that, in order for it to be right, you'd have to position it like this and grind all this material away, which is essentially what I've done with this tool. So you look at these side by side, you have to grind a lot of material away to get this thing in the center. The way that they come, I have a different larger one that I've ground already, for example, and then another one that's not been touched is right. You can see right the cutting edge is more or less across the diameter of the cutting tool, or is in the middle of the cutting tool, whereas this one is not. So you can kind of see the before and after once you grind, so that you have an effective cutting edge, because otherwise you would either be, you wouldn't be, the cutting tool would have the cutting edge on the wrong part of the bore, or if you did position it so that it was in the correct part of the bore when it's cutting, right? So it's cutting in this fashion. You wouldn't have, if you did position this at the outmost edge, you wouldn't have a good geometry on the cutting tool to make a good cut. So this, I realize, is not perfect, but it's better than it was. It's certainly effective in cutting aluminum, but just a little tidbit if you're using one of these cheap boring heads. They work really well, but you just need to be aware of some things. You got that bushing pushed in there, so then let's take this guy to its final dimension. Somewhere between 403 and 404. 404 doesn't fit, 403 does. We hit the mark, I think. So let's put it back together and see how we did. Alright. That is much better. There's just much less wiggle. This thing is much, much tighter. Much better. Cool. Done.